All right, how are we doing today, everyone? Today we're going to be focusing on equivalent fractions and how we can find an equivalent fraction when we have a given fraction. So, to start, we're going to take a look at the fraction 1/2. The fraction 1/2, I know I have 1 in my numerator and 2 in my denominator. I'm going to think about how I can represent this with a tape diagram. In a tape diagram, I'm going to have 2 parts because my denominator shows me how many parts I'll have, and I'll have one of those shaded for the numerator. Now my tape diagram represents 1/2. I want to find an equivalent fraction. Equivalent means equal or the same. What's going to be different is the number of parts in this equivalent fraction. So one way to do that would be to decompose each of these parts into 2. So I'm going to go ahead and do that. I'm going to decompose, which means basically I'll just separate or split up. Now how many parts do I have? 1, 2, 3, 4. I have 4 parts. My whole didn't change. What would each of these parts represent? Each one would be 1/4. Here I have 1/4, 1/4, 1/4, and 1/4. These are all unit fractions because they have 1 in the numerator. So now that I have 1/4, 1/4, 1/4, 1/4, I need to think how many fourths are equivalent to 1/2. I know it's not just 1/4 because that would just represent this part of my tape diagram. But I see the part that's shaded is actually 1/4, 2/4. So I can write that up above. 1/2 is equivalent to 2/4. I know this because I can also look at what happened to the numerator and denominator. In the numerator, we doubled it. We times it by 2. 1 times 2 is 2. In the denominator, I also times it by 2. 2 times 2 is 4. So I can see that 1/2 is equivalent to 2/4. I could also show this using a number line. So here I'm going to draw my number line. When I'm drawing a number line, I want to make sure I label my endpoints, 0 and 1. What is my first fraction? 1/2. So I know I need to decompose or separate my number line into 2 equal parts. Now I'm going to label my halves. Starting at 0, how many halves do I have? 0 halves. 1/2 and 2 halves. Good, because 2 halves is equivalent to 1. On the bottom, I'm going to use the same number line to find an equivalent fraction. Same thing, just looking at this part, I can decompose that in half and decompose this part in half. Now I have fourths. So I can label 0/4, 1/4, 2/4, 3/4, 4/4. Be careful, some of you have skipped this one when you're labeling your fourths and you write 0/4, 1/4, 2/4, 3/4. But that doesn't make sense. We need to make sure we label this. Now I'm going to look on my number line for 2 fractions that are at the same point. And I see 1/2 and 2/4 are at the same point on my number line, which means they are equivalent fractions. They're the same distance from 0. So I know 1/2 is equivalent to 2/4. Let's try a different one. This time, I'm going to let you solve more of it. So I want you to find an equivalent fraction to 1/3. What's an equivalent fraction to 1/3? First, I want you to show it on a number line. I'm sorry, not on a number line, in a tape diagram. So I'm going to draw my hole. As you're following along. Here's my hole. To show the fraction 1/3, how many parts do I need to divide this hole into? Go ahead and do that first. And shade and label your fraction. You should have something that looks like this. Is that what yours looks like? Great, because I have 1 shaded of 3 total parts. Now, how could I find, like we did in the previous example, how could we find an equivalent fraction to this? I want you to go ahead and show that. Maybe by breaking up or decomposing each third. If I decompose each third in 2 parts, now how many parts do I have in total? I have 6 parts. 1, 2, 3, 4, 5, 6. 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. Now let's take a look. 1/3 is equivalent to how many sixths? 1/6, 2/6. So I can show that here. 1/3 is equivalent or equal or the same as 2/6. Is there another fraction that might be equivalent to 1/3? Let's draw another model to show 1/3. What would happen if this time, if I decompose each part in 3? In 3 parts by drawing 2 lines. I still want equal parts. Now, how many equal parts do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9 parts, which means I have ninths. How many ninths are equivalent to 1/3? I want you to write that here. 1, 2, 3 ninths. So by doing this, we have just shown that 1/3 is equivalent to 2/6 is equivalent to 3 ninths. All right, are you ready for a word problem? Let's see. So today I ate 1/4 of a granola bar. I ate 1/4 of a granola bar. My friends ate the same amount in eighths. How many eighths did they eat? important information here in this problem. I ate 1/4 of a granola bar. My friend ate the same amount, an equivalent amount, in eighths. How many eighths, here's our question, how many eighths did they eat? So what is this question asking us to do? I hope you're thinking that this question is asking us to find an equivalent fraction to 1/4 that has eighths in it. So I'm going to represent that numerically. How could I show what I'm trying to figure out? 1/4 is equal to how many eighths? Let's use our strategies that we've been learning to find an equivalent fraction of fourths in eighths. With our whole here I have fourths. How am I going to make eighths? If I have 4 parts and I want 8 parts, I know I can, first I'm going to represent my fourth. I know I can decompose each part in 2. Now, how many eighths did my friend eat? Here, let me label. Up here we had 1/4, but now we have 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8. And I see 1/4 is equivalent to 2/8. Am I done? Not quite. I need to answer in a complete sentence. My friend ate 2/8 of a granola bar. And I can even explain my reasoning here. This is a key step. How can I explain why I know this is true? I know this because I can decompose 1/4 into parts, which are eighths. Eighths. I know that got a little hard to see there. My friend ate 2/8 of a granola bar. I know this because I can decompose 1/4 in 2 parts, which are eighths. All right, so that's a real world example of when we might need to use equivalent fractions. So I'm looking forward to seeing how you continue to grow and work on this in word problems in the future. Awesome job today. Keep it up.